For AP Calculus, note section 8.3, this is video 3 of 3. We are going to be solving logarithmic equations, and we have some guidelines that you can follow to help you do that. There's very similar to the ones we would solve exponential equations with. So it's basically three categories. If the log equation has only one logarithmic expression, isolate the log expression, change the exponential form, and then solve it. If it has multiple, rewrite each side as a single log if it's possible, factor if it's possible, then try to solve the equation if it's possible. If none of those work, use your calculator to cheat. In the end, make sure your solution allows the argument always to be positive. So this example here, this would fit into this category. There's log expressions on both sides. Try to rewrite as a single log. So let's see if we can do that. On the left, we are adding these logs with the same base. So using the product property, we can multiply the arguments together. Now this isn't listed as one of the options. Let's see, we'll put this as 4. These aren't in any specific order. This is if a log equals a log. We want to use the property of equality. Property of equality says if you have a log equal to a log and they have the same base, you can simply set the arguments equal to each other. And then this is simply a factoring problem at this point. If we subtract the 8 from both sides, we get x squared plus 2x minus 8 is 0. This factors into an x plus 4 and an x minus 2. If you set each factor equal to 0 and solve it, you're going to get x is negative 4 and x is equal to 2. We got to be careful because initially we know x has to be bigger than negative 2 and x has to be bigger than 0. Negative 4 is neither of those. Well, I want to be able to see the negative, but then cross it off. X equals 2 is both of those. So x equals 2 is the solution. The negative 4 is not a solution. All right, we got 6 of these to do together. Solve each of the following, round in 3 decimal places if you need to. So if we can get this left side consolidated into one logarithm, which we can, if we multiply the arguments, we're multiplying two binomials. Use the FOIL method, box method, distributed property. Let me take that back. We're not going to do any of those. It says subtract. To consolidate, I take the positive logarithms argument and put in the numerator. I put the negative logarithms argument and put it in the denominator. Once we're here, now we fit into the category of there's only one logarithm. Isolate the log expression. Did it. Change the exponential form. Well, let's see what happens if we do that. So just to be clear, this is log form. I'm going to change to exponential form. I try to make this note every time I do this, just so when you look at it later, you understand what happened. It's not necessary for you to write that on your paper when you're doing homework or tests. So the base raised to the exponent equals the argument. This should be easy to solve. 2 cubed is 8. Trying to solve this equation, we're going to multiply both sides by x minus 1. And then if we subtract x and add 8, we're going to get x is 10/7. Now we need to be careful. We want to make sure here we're saying x has to be bigger than negative 2, and here x has to be bigger than 1. Our argument has to always be positive. 10/7 is bigger than both of those, so that answer is acceptable. Let's check out this little fella. We have natural log equals natural log. Well, the property of equality says if I have one log equal to another log and they have the same base, I can just set the arguments equal to each other. So I get x is -1. They might be alarmed, well, I thought x couldn't be negative. Well, let's see if this breaks any of the rules. This argument has to be bigger than -3. This is bigger than -3, so this works. In other words, if we put a -1 in here, we're going to have -1 plus 3, which is 2, which makes the argument positive. So this is acceptable. Let's see, let's isolate the logarithm. There's only one of them. So I'm going to add 3 to both sides and get log base 3 of 2x minus 1 equals 4. This is in log form. I'm going to change this to exponential form. So that would be the base is 3 raised to the exponent equals the argument. 3 to the 4th. 3 squared is 9. 3 squared is 9. 9 times 9 is 81. If I subtract 1 from both sides and divide by 2, I get x is 40. No, take that back. If I add 1 to both sides, I get 82. If I divide by 2, I get 41. Let's make sure this doesn't break any rules. This here, we would get x has to be bigger than a half. 41 is bigger than a half, so this works. 3 more. Let me make some notes here before I get started. Here, x has to be bigger than -3. Here, x has to be bigger than 0. Just want to point that out. And let's consolidate the left into one logarithm by using the product property. We can write the logarithm, and if we multiply the arguments, we get log of x squared plus 3x. Property of equality says that if you have a log equal to a log, you can set the arguments equal to each other. So I'm going to set x squared plus 3x equal to 10, and then I'm going to get all the terms on the same side, and I'm going to factor. X squared plus 3x minus 10 factors into an x plus 5 and an x minus 2. The factor theorem tells us the answers would be -5 and x equals 2. And then we want to make sure that both these answers are bigger than -3 and bigger than 0. X equals -5 is not bigger. X equals 2 is, so that is the appropriate answer. Next one, this first logarithm, x would have to be bigger than 3. The second one, x would have to be bigger than -1. So as long as x is bigger than 3, then that's going to take care of us here. Let's consolidate on the left to make that one logarithm. So using the quotient property, I'm going to have log base 2 of x minus 3 over x plus 1. On the right, we're going to use the quotient property. It's going to be log base 2 of 3 over 7. Then if we use the property of equality, since I have one log equal to another log and they have the same base, I can set the arguments equal to each other. Well, this is an Algebra 1 question now, although it's complicated for Algebra 1. I want to get rid of my fractions. I'm going to multiply both sides by 7 and x plus 1. On the left, the x plus 1's cancel, and I'm going to get 7x minus 21. On the right, the x plus 1's cancel, and that's going to give, I'm sorry, the 7's cancel on the right. It's going to give me 3x plus 3. Now, if we subtract 3x from both sides, and we add 21 to both sides, and then we end up dividing by 4, we get x is 6. Does that fit the parameters? It's bigger than 3, it's bigger than -1. You betcha. Last one. Let's isolate the natural log by adding 3 to both sides. Now this is currently in log form. Let's change the exponential form. Base of e to the exponent equals the argument. To get x by itself, I'm going to add 1 to both sides, then divide by 2, same as multiplying by a half. Direction said round to 3 decimal places. You put this in your calculator, you get 4.195. That concludes 8.3 notes. This takes practice and patience, and for you to recognize when you made a mistake. What concept did you misunderstand that led you to that mistake? If you can figure that out, then you're going to find logarithms to be pretty easy stuff. Please do the 8.3 homework.